In this class, we will work on data handling using Pandas package in Python. So Pandas is a package which provides fast and flexible way of handling datasets. Datasets can be of tabular data such as SQL tables or Excel sheets. We can also work with time series datasets and also the matrix datasets which contain row and column labels, and also other observational statistical datasets. So it is quite interesting package to work with dataset, especially arranged in a form of row and columns. The first step to install the Pandas. So to install the Pandas, we can go to the settings and go to the project interpreter, and then we can search the Numpy and Pandas package and install it. So let's see how we can install this package. In Python using PyCharm ID. So you have to go to the file settings, and in setting we have to go to the project interpreter and then press plus sign on the right side, and once you will click on the plus sign, you will reach to the search bar where you can click the required package. So we will install Numpy. So I have already installed it, so I will not install, but you can select and install the package. Similarly, you can search Pandas and then install the Pandas package. So once these two packages are installed, then you can see this in your project interpreter. There will be these two packages listed, and then close the interpreter window or settings window. So once you will close it, then you can call it and see if these packages are installed properly. So to do that, copy this code, which is import numpy as mp and import pandas as pd. Paste it in a script file. So once you have pasted it, run the script, and you will see an exit code 0, which means that these packages are installed and this script is reading these packages properly. So now both of these packages are imported. So in Pandas there are two data structures which we will deal with. One is series, which is a one-dimensional, and the other is data frame, which is two-dimensional. Let's see what we mean by one-dimensional. So I will show you here in Excel sheet that what is meant by one-dimensional dataset and what is meant by two-dimensional dataset. So let's open Excel. This is just to show you that what is meant by one-dimensional and two-dimensional. So in series dataset, there are indices and corresponding data. So in a series you will have only one column, and that column of dataset will be associated with an index, or you can say a primary key. So here index is ABC and your data is 10, 20, 30. So this is basically your series dataset, which is one-dimensional set of array. Then you have a data frame. Data frame is a two-dimensional dataset, which means that you have an index and more than one columns. So you will have more than one columns in your data set. So I'm giving it a name as data 1, data 2, data 3, and there are corresponding data sets below it. So index, all of the columns are indexed. There is a common index and there are more than one columns. So when you have more than one columns, it's a data frame, and when you have one column, it's a series data set. So series is a one-dimensional label array capable of holding any type of data. So you can put any type of data in the series object, and it is accessed or labeled by index. So you have an index and a data set. So let's see how we can create a series in Python. So for that you will need a method or a function called series. So in Pandas package, which we have called as pd.series, and then you will need data and index. So let's see, or let's create one series. I will show you on the Python how we can do it. Let's call it as S. So we can give any name. So I'm giving it as a S. PD is pandas dot series, S capital. So now you have to enter data and index. So we will put this list as a data set, and index will be a list of your primary key. So it can be integer or it can be string. So I'm creating one series data set. Let's do it same as we did in Excel sheet. So I will put data as 10, 20 and 30. And for index we will take A, B, C. Now you have created a series data type and save it in S. So you can click the run script. So you will see there are like 3 data points, which is 10, 20, 30, and ABC are your series indexes. We can also see which data is our index by using s.index method. So you can also call the data by using the indices. Suppose if I put SA, so it will send me the data which is 10 corresponding data. SB will be 20 and SC will be 30. This is how you call the data sets using the indexes. So you can also create series using a dictionary. So a key in the dictionary will be your index and the corresponding data. So let's do it here. So D parenthesis open, which is then the key, and after key you will put a data separated by a comma, then another key, then corresponding data set. So this key will become your indices in series data type. So now I have to call this series pd.series, and in the bracket I will give dictionary. It will automatically assign keys as indexes and corresponding data. So let's run it. So now you can see that your S2 is automatically created from a dictionary, or series is automatically created with the dictionary. So there are different methods how you can call the dataset. One is you can also call by using the index numbers. So it's not index key, but it's just a number. So 0 as 0 will be same as S inverted commas A at 0, because at 0 you have the data value which is 100. So there are two ways you can call the data from a series. One is by using the index or label, other is using the iterators like 0, 1, 2, 3. You can also directly calculate statistics using methods which are embedded in the series. So s2.mean, so you calculate the mean. So you can see the 200 is the mean of the data set. Similarly, you can calculate the median s2 dot, so you can call this method series method to calculate the median value. So now let's see the data frames. And as we saw earlier, the data frame is a two-dimensional data set, which means you need an index and more than one columns. So it's kind of multiple series aggregated in one data frame with common index. So that's how it works. So there are different ways to create it. One is this example, creating a dictionary. Then this 1 and 2 will be the column headings, and this 1, 2, 3, 4 will be the corresponding data. So let's see and do it in Python. So we can give any name to the variable. So I'm giving here as df is equal to pd dot data frame. Now as previously we took series, now here we have to take data frame. So you can directly put the data in a form of a dictionary here in the function, or you can do it separately. First, as we did earlier in the series, is first to call the data, and then first to develop a dictionary and then call the dictionary in the function. So let's make it a dictionary. So you have to put the flower brackets. Now we can also do it like separately. So I'm doing it, assigning it d2 as a dictionary 2 variable, and for column 1, then column 2. This key in this case will become the columns of the data frame, and in this case where we are calling directly, the index will be generated automatically. So let's change a little bit of data so that we can visually see the different data sets, because here last time we just copy pasted it. So I'm just making it like a different data set in each column. So we will now create this or replicate this structure. You can take integer values 10, 20, 30. In column 2 we can put like 15, 25, 35. And in column 3 You can put 100, 200, 300. So now simply we have to give this d2 as an argument to pd.dataframe, and now we can print it and see how it looks like. So now you can see that there are three columns: column 1, column 2, column 3, and 0, 1, 2 is the index and the other is the data type. So just to synchronize with what we have in Excel sheet, I will put the names as data 1, data 2, data 3. Run it again and see. So this is same structure as we have in the Excel sheets. Now we can also create our data frame using different series. Each series will act as a column. So this is another way of creating a data frame out of series. The other way is to read the external file and save it in a data frame. So there is one function which is pd.read csv. So let's do it, both methods in Python script. So we'll create a data frame using a series object. So I will name it as df2. So now what you need is a series, and then to assign the names you have to create a dictionary where you will give the name of first column and then give a series to it, and the other column and give a series to it. So this data set we have to enclose it in a dictionary, so I will write it and then put a curly brackets around it. So here I did a mistake, I forgot to put curly brackets, so I will, because this data set has to go in dictionary format. So here you can see that I first created the dictionary and then called the dictionary in the data frame. So I'm calling here directly, so I will put a dictionary structure. Let's run it. So now you can see how I have created a data frame using series object. Now you can also create a data frame directly importing the Excel file by using read CSV function. So now we will see how we can do it. So we will import a CSV file which is sucker.csv given to you. Just give it as data frame 3 df3 pd.readcsv, and in read CSV you just have to give the name of that CSV file. Now print it. So now you have date and inflow, and index are 0 1 2 3 4. There is one way is what we can do is convert this date column into a date time format of Pandas and then use it as an index. So this is really handy because it provides you freedom to call the dataset by the date time values. So here we will do indexing. So we will index date column our dataset with date time values. So first step is to convert this date column into a date time format, a standard format of Pandas, and then use it as an index to the dataset. So let's do it. First step is to convert it to a datetime format with a function which is pd.toDateTime. So here what I'm doing is I'm just converting and saving it into the same column. So you can see how we will do it. So df date date. Now what I'm saying is that go into this data frame and take this column and save the data whichever or the process I'm doing it now. What I'm doing it is converting this column into a standard datetime format. So there is a method to do it. It's pd.datetime to datetime, and in bracket I will put that column which I want to convert, which is same as def date. So here is one mistake I did, like the CSV which I have read is in variable df3, so I have to change that df3. This error will occur. So now df.index. So once I will run this, I will have an error because the CSV file is saved in df3, so I have to change it to df3. So now I've successfully converted my date time into a standard format and indexed my data with this datetime format. Now I can delete this date column because I don't need it, because I have indexed it out. So I will use a function del delete, then give that column. Simply delete df3, then name of the column, which is date. Now I can print and see it. So here now you will see that my date column will be vanished, but my date and time will occur in an index format. So now here you can see its date and corresponding data set. So arranging in this form, like I have now freedom to manipulate all of the data set using time and also calculate the statistics based on the time. So there are different methods which you can use to calculate the statistics. So we will do step by step each in this dataset of sucker.csv. Now let us calculate the statistics. So there are different statistics we can calculate on the dataset we have in inflow column. So here are some of the examples like skew, kurtosis, quantile, maximum, and then getting the maximum index, which will give us the date of the maximum occurrence of the flood or maximum discharge. So let's calculate. So you have to write df3.mean. You can assign the column, or you can simply tell df3.mean because we only have one column in the data set. So I will run it. So I'm printing df3.mean. So this the output would be the mean value of the whole data set. Now similarly we can calculate other statistics. So to get the maximum value, I will use df3.max function. So my maximum is 1200574 Q6. So calculating the skewness in the data set. So you can also calculate the quantiles. So I will copy this So you can assign the column as df3 bracket inflow, or you can simply do it, because in this case we only have one column. But if we have more than one columns, you need to specify the column where you want to calculate the statistics on. So there is also another way. We can use only one function which will calculate all of the statistics or summarize the statistics of the data set. In that case, we can use a function called describe. So it's df3.describe, so you can calculate all the statistics using that df3.describe function. So you click this df3.describe, it gives you standard deviation, minimum, quantiles 25, 70, 50 and 70, and maximum value. You can also export this statistics which you have calculated by using a function where we can save the all statistics in one object and then use function toCSV. So I will show you how we can do it. So I'm saving it in an object called name summary, or a variable name called summary. I'm saving all the statistics. Now I can export it to CSV. In CSV I can give the name as statistics.csv. So if I run this, there is some error. No, I think data transform is just giving the warning. So here you can see all the data set statistics of the data sets is calculated and exported into a CSV file. Now there is another way of working in time series data. Sometimes what happens, you have daily data sets and you need to convert it to seasonal or annual averages, monthly averages. So in that case you can group your data set using the index, date time index, and then you can calculate the statistics based on annual, monthly, or as you wish. So here we will do annual averages and see how we can group our data set and then calculate annual averages, and then you can also export it to a CSV, this transform data set, as we did earlier in the statistics case. So here is the example. So I have created an object df year which is equal to df3.group by df3.index.year. So what it is doing is it's grouping all the data set yearly basis and storing the information. Now you can apply statistics on this df year object. Suppose you need data set for mean data set for every year, or you need maximum data set for every year. You can simply write the function mean or max on this grouped object. Let's see how we can do it. So I'm giving a name of the object which is df annual mean, which is equal to df year dot mean. So it will give me mean averages. So I'm just commenting other prints so that it doesn't look so much messy. So just run the script. Once you have run the script, so it will give you yearly mean values. It's quite straightforward. You can see 61, 62, 63, 64, all of the years, and this flow is the mean. Our original data set was in daily time step. Now we have annual averages. Now you can similarly calculate, suppose you want to see the maximum flood in any year. So you can use df year dot max function, which will give you the years where you will find flood peaks. So I'm giving object name as dfa maximum. So df year dot maximum function I will use. So it will give me maximum flood peaks in every year. So now you can see that it has grouped the dataset with year but with the maximum value. So now you can clearly see where in which years you had the flood, like in 1972, 73. In 73 you had one flooding event. Then you have in 75 and 76, then 78, and so forth and so on. Like in 2010 we had one peak. So this is an example how we can group based on the date time format. And there are many things which we can do using these basic tools, and we will see in coming exercises how we can use it for the analysis purpose. Thank you very much, and practice all these stuff and be ready for the next class